All right, logical volume management. Let's go and get started. Let me go ahead and go over some of the boring part while I'm kind of getting all my stuff together and people get settled. Linux for LVM, or LVM for Linux, was created by Heinz. And does anybody know German? Can you pronounce this last name? Because I'm butchered it every time I tried. It's He actually modeled it after HPUX. He'd been working with HPUX. And a lot of different Unixes have some sort of volume management. He'd been working in that environment. Noticed Linux didn't have anything. So he said, well, I like the way these guys do it, and I'll go ahead and write it. And his first implementation was in '97. It was called LVM1, and which was a little of a misnomer because you ended up with LVM1, but it was actually LVM.9, the actual release number, but it was Format 1. Then the Format 2 came out in, it was hired by Sistina and started working on LVM2. It released in 2003, and it was bought by Red Hat. So, but it is an open source project. You know, it's completely GPL. Red Hat doesn't own anything, really. They just hired the guy who actually maintains it. Okay. There we go. Why should I care about LVM? Okay. Well, that's actually a question I get asked quite a bit, and that's one of the reasons why I wanted to do this talk, is because a lot of people are like, well, make my life difficult. Why do I need to deal with it? Because Linux is not Windows. I would imagine everybody here kind of understands that point. But unfortunately, I find that on the forums and IRCs and a lot of different areas, people actually don't think they're different. They think that I can do them the same way. And so that's kind of what I'm hoping to kind of go over a little bit, and also to go over kind of why LVM is good to use in a Linux or Unix environment. So as far as Linux is not Windows, usually you maybe recognize this, where you've got basically one C drive, one big partition, one NTF file system, and that's it. And you fill it up or until it crashes, one of the two. So that's kind of all you've got. But in Linux and typically in Unixes, you separate out your disk into different partitions, and then you build different file systems on those partitions. And so you have everything kind of broken out. And there's some method behind it. Basically, Unix or Linux structures, they basically have a file hierarchy, and everything is kind of put in place for certain reasons. So boot is typically where you're going to have your bootloader configurations, kernel files, and .RDs. /root is going to have all your low-level commands that you absolutely, absolutely positively can't go home without, kind of thing. And then user is going to have things that you could live without, if you weren't in single-user mode. var, temp files, homes where you're going to keep all your pictures and music and whatever. And opt is where you're going to store a lot of third-party applications, a lot of vendor stuff. And you also have swap space. So you'll actually set aside a partition for that. So why make our lives so complicated? Why can't I just put everything in one big partition? I mean, that was what Windows does. Seems to me make my life simpler. You can, absolutely. But there's some drawbacks to it. So first off, the old adage, don't keep all your eggs in one basket. And I think that that's probably one of the biggest reasons why you'd want to break everything up into multiple file systems. Again, like we talked earlier, you had /boot, /root. These are all those critical things. So if you've got 10 other file systems set up and one of them happens to be corrupt because that's the one you're constantly doing reads and writes to, well, you're okay because the other ones are still, the critical ones are still okay. But if you have to put everything into one big root file system, which is what you're seeing oftentimes these days, is that you corrupted something because of, the system went down or whatever in the middle of a write, and you've lost everything. And so now you're digging through trying to find either the install CDs to get into rescue mode, or you've got to get a Knoppix CD out, and you've got to run fdisk. And, it's a lot easier to be able to bring up the system to fix one little problem. So what you want to do is you want to segment everything out. Now, because root and boot aren't written to all that often. I mean, you kind of set up the system. They're kind of, we read from them, but we don't really, write a lot to those file systems. The chances of those actually becoming corrupt because of a write or because of some other issue going wrong with the system in the middle of that, where the file system gets corrupt, is a lot less. So if you've got, like, var would definitely be a file system that's more likely to get corrupt than anything because you're constantly moving files around. So that's one of the big issues. You want to separate everything out. One of the things that I've heard people say is, well, Yeah, but I'm not running servers. I've just got a home system. It's my laptop, that sort of thing. That argument is completely backwards. I run servers, and they have redundant power, redundant internet, or redundant Ethernet or whatever. They've got RAID disks. I mean, there's so much redundancy going on with my server that the chances, in a locked cage, by the way, nobody can get to it. But my laptop, my kids come by and they slam the thing, and hibernation doesn't work. I forget to plug it in. They trip over the cord. Somebody's running the vacuum cleaner and the microwave at the same time. Things happen with desktop systems, with laptops. Those are the systems that are actually more likely to go down. But people think, well, because I'm not running a server, I don't need to do all these things. I'll be okay. Well, you find that if you have to, if you lose all your data or you've lost everything, it makes your life a lot more difficult sometimes. It may not lose your job, but it does make your life a lot more difficult if you're going to have to redo everything all the time. So you can have different file systems for different uses. So, instead of having just one choice, I mean, that's what Linux is supposedly all about, right? We're supposed to be able to have different choices. So if you've broken everything up, make one of them ext2 because it's really stable, and you you can get to it with any kind of distro or recovery CD or whatever. You can typically mount up ext2. You don't need any modules or anything to get to it. You might like, and I haven't played much with ext4. I've heard some good things about that. Riser FS, because I like Riser beyond the other reasons that are bad about it. But one of the things I did happen to like about Riser and JFS in particular is because I can actually grow those file systems without having to unmount them. So that's one of the reasons why I particularly like those. So certain file systems that I know I'm going to grow them, or I know that I'm going to need more space in the future, those are where I build them on. You can also have different mount options. So for different file systems, let's say you want to make one read-only, or you want to no SUID. I mean, these are sort of things that you have all these options, but yet, again, time after time, I'm seeing a lot of systems set up, again, one big partition, one big root. Let's keep it simple, but you lose out on so many different benefits. And here's one I don't think a lot of people understand or realize, is that and contiguous, by the way, is a real word. If some people do know about that. I had a lot of people go, you got that misspelled, when I was actually running this through people who weren't technical. But basically what you want to have is that, again, we were talking about where you don't do a lot of reads and writes from your root file system, but you might within var, or you might within other file systems where you're actually changing a lot of data. And so if you've got everything segmented out, you're keeping those write heads, you're keeping that seek time down because you're keeping the write heads kind of separated out in certain areas. So if you're doing lots of writes and reads all the time, but again, one big file system, you've got that seek, you've got that stylus going all over the place. So it does cut down on some seek time, and especially with this being slower these days than they were, which is, you would think that, well, they'd be getting faster. They're getting larger, but the speed is not keeping up with the capacity. So you end up with these gigantic 750 gig, terabyte disks, but the actual seek time hasn't really increased. So if the seek time hasn't increased, but yet it's so much more data, and I put everything in one big file system, things are going to really start slowing down quick. And so you do want to kind of segment things out. It's just good practice. So where can it go wrong with this, now that I've sold you on multiple file systems? Well, this is a little history for me. My first Linux box in 2000, I was running Linux Mandrake before they went through about 3 different name changes after that. And I didn't know what I was doing, but at that time, everything told me you need to partition your drives, you need to build your different file systems on it. And I kind of went off of what I could find on the internet and what little information I could find. And I said, well, okay, 512 meg, 512 meg, 512 meg, 256. Swap's got to be double. So I said, okay, I'll make it 96, which, by the way, I still see people going, I have to do double swap that I have in my RAM. And I was like, so they're trying to make 8 gigabyte swap devices. And I see this all the time, and I'm like, okay, guys, it's if you run out of swap. That old adage of double doesn't fly anymore. You don't have to do that anymore. But at that time, you did. And then I ended up, when I got done with that, I thought, well, those are the ones that they tell me I'm supposed to do. And I ended up with a little extra space, and I thought, I'll figure out some use for that later. So after a few months of playing around with Linux, I downloaded some RPMs, and user started filling up. In fact, user completely filled up. I couldn't do anything more into it. Root, still pretty empty. Var, completely empty. And I'd started filling up home because this was going to be, hence Big Red Radio, if you've seen that. I used to have an online streaming radio station. That's what this was all originally designed for. And so I'd filled that up with some MP3s. And again, I still had this 160 megs of free space, but I couldn't put it back into user. There was nothing I could do with it at that time. So once you've actually created partitions, now a lot of people will say, well, you can use this app or you can use this and you can actually change the partitions and you can do this. The processes that they do to do that is very kludgy or scary. Have a good backup. I'm not saying you can't do it. You can change the size of partitions, but be careful with it. Now, again, if it's a root partition, it's not going to happen because you need to take the thing offline before you actually start doing that. And it's just not good practice to do it. Your chances are you're going to lose data more often than you're going to be able to do this successfully. So, how big do you make the partitions? I mean, only as big as you need to. Now, it's a strange concept. You only make them as big as you want, as big as you need to cover the amount of space you had. The reason why I've got IBM in there is because when I learned LVM, my first introduction to LVM was not through Linux, but it was through AIX. And I went to work for a company that specializes in AIX software and was doing Linux. So I was hired on for Linux into an AIX shop. And so we sat down, and I sat down on my first box, and I look at a file system listing, and every file system is like 60 to 80% full. But I look at the amount of data, and I knew how big the disk was, and it didn't add up because it was like only 2 gigs worth of data, but everything is almost full, but yet this is a 9 gig disk. I'm like, what's going on here? Where's all this extra space? And what I didn't realize is what a lot of different Unix environments, AIX, these guys have learned for years, is that, well, you need more space in one of the file systems, you just grow it a little bit. Need more space over here, you just grow it a little bit. You don't have to anticipate roughly. I mean, you have to do some anticipation as to when you install the system, but once you've got it set up, you just add as you need as you go along. And they're just kind of very accustomed to doing this. This is a very common thing. And for me in Linux, I thought, well, this is completely backwards. You don't want to do that. But the more that I've done this and the more I've seen where it comes in really handy, where I'm like, oh, I'm starting to run out of space. Okay, let me get myself a couple more gigs. I mean, it's a really nice feature to be able to do that. And again, I'm not making some file system that I'm not even using, so big, and I've got all this extra unused space. So you can actually efficiently use your disk space. So what is logical volume management? It is a method of allocating space on mass storage devices using a storage virtualization implementation as a layer in the OS driver stack. That's probably one of the biggest problems, I think, with LVM. You're going to get a definition like that when you start to go look it up. You go to Wikipedia or something like that and say, I want to learn about LVM. Let me go look at the man pages. And you end up with something like this. Well, I'm a developer. I understand that developers write for other developers, or they wrote the software to begin with. So, they don't think in terms of somebody who's new who has no concept of it. So this, by the way, this talk is really a Hubble telescope view of LVM, if you haven't already figured that out. So here's my translation. It takes disk space, converts it to a flexible format that you can use, and you can actually grow these devices that you build these file systems on. So again, multiple file systems, you put them on these devices, well, let's make those devices interchangeable. And my definition is Legos. And I think, actually, when I signed up for this talk, after a couple of margaritas, I told them, they asked, in the questionnaire whether or not I needed a projector, and I said, no, I'll do it with Legos. Beknownst to me, it actually made sense later. I was thinking about it. I was like, actually, I could probably do this talk with Legos. So there's 3 main components to LVM. You've got physical volumes, volume groups, and logical volumes. Physical volumes. Physical volumes are the disks, partitions, other devices that you've allocated or flagged to use with LVM. So you basically say, okay, this partition or this disk or whatever it may be, this meta disk, if you're doing software RAID or whatever, I'm going to say, I want to use this for LVM. So you flag it. Volume groups. So you start adding all this stuff together and say, okay, I got this disk, I get this partition, I got this meta disk. I'm going to pull that all together. That's going to be my volume group. That's where all this storage is going to be, the storage pool that I'm going to keep. Logical volumes. Again, these are the little pieces, the things that you create that you build your file systems on. Okay, these are, and note, resizable devices. Resizable can go both ways. So let's say you overestimated, you made it a little too big, and you're never going to fill that up. Who said that many times? But anyway, you can shrink the logical volumes after you're done without losing data. Whether you can do it, you can't do it online. That's the one drawback to it. So make sure to make at least the boot, make sure to make the root file system large enough, because you can't really take that one offline. Okay, so how does it work? Well, physical volumes are broken into small chunks called physical extents. And these physical extents are the building blocks. So back to my visual aid here. This is my 80 gigabyte drive. And here's another 80 gigabyte drive. Okay, these are my logical extents. By default, I believe they're 4 megabytes. You can make them pretty much any size you want, but I think it's like the limit is 1K, and the upper limit is like a terabyte. So you can pretty much get it. You can pretty much say they're any size you want, but by default, they're 4 megs. And so you can take all these disks. You kind of put it in here. The volume group is your bucket. So your physical volumes, again, are these. You break them up into your logical extents. You put them in your bucket. Now your bucket is your volume group. So here's your volume group right here. Your logical volumes. Well, your logical volumes are the devices you make now that I'm going to build this file system on. I got this whole bucket of Legos here, so I want to make it this big. And I'm going to make one, let's say these are already there, but I'm going to say I'm going to make this one a little smaller. And I need to make this one a little bigger. I like Legos. I got kids, so I play with them all the time. So you can extend the logical volumes by adding more Legos. So you start running out of space, no problem. I got more Legos to play with. I can add more space. And that's kind of how you can add things. You can either add things by, hey, I need 1 more gig, or give me so many more physical or logical extents. Now, I use them interchangeably. They're really not. When you're talking about physical volumes, at the point where you're breaking them up into your volume group, they're actually called physical extents. At the moment that you're building them out, when you're taking them out of the bucket, they're actually logical extents. And other cool things about LVM. Well, you can move, again, you can take multiple disks, different sizes, SCSI and IDE living together, mass hysteria. You could really mix up your environment because you may have a mixed environment. A lot of times, you can't buy an IDE disk these days, and not at least it's on eBay, and it's already used. Everything is basically SATA. At this point, it's probably going to be, flash drive next week. So you need to be able to say, okay, I've got completely different disk types. How can I actually add all this stuff together? So you can add that to a pool. And again, you're adding it to a pool, but you're not creating new partitions and things off of these disks. You're adding them to the volume. So it may be adding more space to an existing home file system. Probably rush through. I'll answer questions after.
I was just saying, they can all be done online, too. Like if you have a hotspot drive, they can all be done online.
I'm getting there. Okay, other things that are cool about LVM. It's a good replacement for software RAID 0 and 1. Doesn't do a RAID 5. But you can stripe data across to physical volumes. So you can actually set it up in such a way that if you have, let's say, a couple disks that you're using as physical volumes, you can specify and say, use a little here. And you can say, okay, make these striped, make them copied. That's where you get your performance redundancy. So it's kind of nice. Now, a lot of people will build LVM on top of RAID. If you're doing RAID 1, you don't have to. I mean, you can actually do it at this level. If you're doing RAID 5, then yeah, you'll build LVM on top of RAID 5. And again, RAID 5 is going to take all, the disks, put them together. It's still going to show up to the system as one disk. And then you make that a physical volume, break it up into your little pieces, make your logical volumes out of it. And then if you run out of space or anything like that, if you're not adding it to the RAID volume, take another hard drive. Now you've got this RAID 5 and you've got this other hard drive as part of it. Probably not the best practices, but it's possible. Other cool things about LVM. You can create snapshots of logical volumes or point-in-time backups for live data. This is a moment of contention. I've talked with different people about this, but Linux doesn't really have live data, not at least in the sense that Windows does, because oftentimes Windows uses locking mechanisms. Well, Linux doesn't really have a locking mechanism. You open a file, it's in memory, and there it is. You've got the other file sitting on the disk. It's pointing to an inode. So it's, what are you working with? That's why a lot of times you'll create a swap file. But there aren't really live data, so to speak, I guess. But technically, you could say, okay, databases, VMware instances, those things can be considered as live data. Something that you either have to shut down the database, or you have to shut down your virtual machines before you can back them up. The backup will run fine. You can back up. I work for a backup company. We make Linux backup software, and people back up databases all day long. And it's not until I tell them, you shouldn't do that, and they're like, well, the backup worked fine. Sure, but have you tried the restore yet? No. It's like, yeah, try to restore that Oracle database after you backed it up live. Chances are that thing's going to come back either complaining or just not work, period. So, like I said, typically, unless you're using some product within, you actually have to shut these things down to actually back them up. Not if you're using LVM. You put that thing on a logical volume in that file system, you can actually make what's called a snapshot of that logical volume, a point in time where it basically stops and says, okay, freeze, make a copy. And over here you've got this copy that you can back up frozen. So over here, the database is still running, they're still doing transactions, everything's still going on, your VMs are still running, everything's going. But over here you can back this thing up safely. After you get done, just get rid of the snapshot, everything's going. But beyond that, that's one of my favorite album covers. What are the cows about? Well, it's called copy on write. Because if you thought about it, you'd go, oh, I make an exact copy. So now I've got, 100 gigabytes. I made an exact copy. Does that mean I need 200 gigabytes? No. What it does is it creates a snapshot logical volume that's only a percentage size of the original. And the only thing that it contains, data-wise, is changes that are made during the snapshot. So you've got the snapshot over here. It seems confusing, but you got the snapshot over here. You make a change. It copies the original over. So that way you're still accessing the original, but the changes are actually being made. So what ends up happening is you have what's called a copy on write, or it's called a cal table. That's the index that sits inside the snapshot as to know what's changed and what hasn't. So you end up with making a complete copy of it, but using very little disk space to do it. How am I doing on time? Anybody know? Am I over? Getting there. All right, cool things. Just like the gentleman in the back was about ready to talk about, you can actually take those physical extents, and let's say you've got a disk that you know is going bad. Now, typically when you know it's gone bad, it's because it's dead. But if you do have some indication that there's some problems going on with the disk, you can actually there's a command within it that actually moves those physical extents from one disk to another. So it's like a lifeboat. You can basically say, okay, I got disk space sitting in these other disks. This one's going bad. Let's move their data over to another one. Basically, let's abandon ship. Let's get off to some other disk that has space. And again, you're not moving files. You're moving the low level stuff. So what happens is you can actually do this online. That everything is still working. You can actually just copy everything over. You didn't have to unmount the file system. Everything got moved over. Typically, it's still good to have a backup of everything, but you can do that. Then if it's a hot swap disk, you can actually yank that thing out of production, put in a new disk, put it in. Again, run the simple command to actually turn it back into Legos. It goes back into your volume group. Now you got all this free space again. The LVM commands. One of the things about the commands that Heinz, when he wrote it, wanted to make it simple. And in fact, most LVM commands and other Unixes are pretty simple too. PV create, that's the command I talked about designating it. VG create creates the volume groups. LV create, you're kind of getting the picture here. LV display, VG display, PV display, it kind of gives you all the information. Guess what LV remove does? Or VG remove. Pretty simple. That's the nice thing about it. But if you didn't know what PV, VG, LV, all these things mean, you'd be like, what am I supposed to do here? I don't even understand what this stuff is. And then last, if you do have any more questions about what are the capabilities, you can go to the Debian help desk. And there's a lot of different information here as far as what the different commands can do. So this hopefully gives you kind of a very Hubble telescope view of what logical volume management is, so that when you do go back and read the documentation, this stuff all makes sense. You're like, oh, okay, I know what a physical volume is. Those are my Legos. I know what this is. I know what that is. And so, thank you very much. Probably we'll have to get out of here, so I'll answer questions afterwards if you have other questions, unless the other speaker's not ready, and I'll answer some questions now. Yeah. I don't know if I can answer them, but I'll throw it out.
Can you shrink a physical volume?
Shrink a physical volume.
So I run into these problems where when I install a distro on a fresh drive,
Uh-huh.
It takes up the whole thing with the LVM and all that stuff.
Uh-huh.
And I need to shrink it in order to install another disker because I tend to do whole or triple boot.
You can, at that point, what you're talking about is once you've designated that partition itself as your physical volume, now we're getting back to can you shrink a partition itself? Because essentially your physical volume is on SDA1 or whatever, SDA2 or whatever the actual partition is. It wasn't actually that disk. It's that partition. And so that partition size would need to change. You can, there's in fact, PV shrink, I think. Yeah, I believe there is. Yeah. I was just thinking about it. It's like, wait a minute. Yeah, I haven't used that very much because usually you're more throwing things into the bucket rather than taking things out. But yeah, absolutely, I believe you can. And I. Mm-hmm. Sure.
So you're saying that the advantage of breaking things up was that you could lower your seat times and stuff like that.
Mm-hmm.
However, you were saying that you recommend make your volumes as small, your logical volumes as small as possible, so that you can extend them when you feel like it.
Right.
How do you avoid getting massive fragmentation that way? I mean, it seems like that would actually make the seat problem worse, because if you're extending them all the time, you're going to end up with.
Because actually, the lower level is actually handling the data. Basically, because they're broken into these extents. The idea on contiguous data, it's not necessarily continuous data. It's contiguous in the sense that it's closer together or keeping it separate. So that way you keep the heads area. If they have to go over here but they're still together, that's okay. What LVM is going to do at a lower level is it's actually going to lay things out in some logical sense. And you're adding more of these Legos to it, but it's still keeping it in certain areas that's going to help reduce seat time. So it's not unlike file systems where it's kind of, let's find a place for it. It's actually saying freeing it up, but it's doing it in a lot more logical way to keep the data more contiguous underneath the covers. So the performance is not as good though. If you break up a file system into partitions, you get better performance with partitions than you will with LVM. But again, there's a trade-off. So. But it does actually a really good job. It doesn't lose performance. That was something I kept in mind when they were actually writing it. So.